Hello class, this is my first instructional video ever, so I'm sure to make some noob mistakes. I'll be presenting the McCulloch and Pitts neuron, also known as the MP neuron or the MMP neuron, as presented on pages 80 to 81 by Robert M. Harnish, the author of our main text. So this is the McCulloch-Pitts neuron. This candy corn thing here is the main body. It takes some input, it is weighted input, and it produces output unless it's inhibited, right? Under certain conditions, if it's not inhibited, it will produce output of either a 0 or a 1. We call this the all or none rule. So all is the 1 and the none is the 0. Nothing higher, nothing lower, no negatives, nothing in between. Same goes for the inputs. We have 0 and 1. All or none rule. This is not biology. They're not trying to do neuroscience, neurology, or biology in the sense of saying what biological neurons do. These are artificial neurons, and they're just asking how might these things process information? What could be done with them if we had things that follow these kinds of rules? Now here we have the Greek symbol epsilon, and it represents summation. So whatever comes in here gets added all up, and you get a sum. Here we have the Greek symbol theta, which represents threshold. And the idea is, as long as this thing is not inhibited, then if the summed weighted input meets or exceeds the threshold, you get an output of 1. Otherwise, you get an output of 0. Okay, so there are different ways that could happen because that you could get a 0. Maybe it's not inhibited, but the summed weighted input is just not high enough. It does not meet or exceed the threshold. Or maybe it does, but it's inhibited, right? So the inhibitor kind of just pulls the plug on the entire thing, keeps it quiet, so its output remains 0. Now here I've got the 3 inputs. There could be 4 or 5. There could be 1, 2. It could be any number, any finite number of inputs, and each is weighted. Right now the weights are boring. They're all 1s, but we'll play around with it. Let's set let's set the threshold to 2, right? And then let's go 1, 0, 0. So the input here is 1, then 0, and you multiply 1 times 1, right? And then 0 times 1. This is, I hope you can see where this is going, right? Obviously, the sum of the weighted input is not enough. It does not meet or exceed 2. So whether it's inhibited or not, you're going to get a 0 over here. It's just not enough summed input. Let's change the input. This should not be surprising at all, but might as well go through it, right? 1, 1, 0. Then we have a 1 times 1, which is 1, and another, and then we go like that, right? We have 2. That meets or exceeds the input. So, I'm sorry, this 2 meets or exceeds the threshold. So does it fire? Well, be careful. We have to make sure it's not inhibited. If it's not inhibited, you get an output of 1. If it is inhibited, it doesn't matter what's going on here. You get nothing. Okay? Let's go back to what we had and change the weights. Okay, so this means I'm going to do some erasing, and let's make this weight be 2, and let's make this weight be 0.5, right? And keep the threshold at 2. Then what do we get? Well, we're going to get a 2. 1 times 2 is 2. 0 times 0.5 is 0, of course. Then we get another 0. Okay, is this going to fire? Well, it will as long as it's not inhibited, because it meets or exceeds the threshold, right? Want to do one last one? Yeah, what the hell. Let's erase all that. And, I don't know, make this, a 0, don't write with an eraser, no, a 0, and a 1 and a 1, and so what do we get? We get a 0, and we get a 0.5. I don't know why it won't make dots very easily, and a 1, and this is just not enough. Kind of a letdown, huh? You want it to fire, don't you? Okay. So this does not meet or exceed, so it doesn't even matter. Now, if I change the threshold, what if I just had a different threshold? Threshold of, say, 1, then of course it will fire. Unless it's inhibited, right? So I hope it's been pretty straightforward. Sorry if I made some noob errors, like I said. Hope they weren't too irritating, and possibly were maybe a little charming. All right.